This is just a qualitative direction question real quick. Chloride ion is placed at location C. What is the direction of the force on the chloride ion? Okay, so we're looking for the electric force on a charge, a negative charge placed at location C. So think about what you need to do to figure that out. From negative to positive, by the way, for a dipole moment. Six is the direction of the electric field because it's pointing, electric field is pointing towards the negative charge. But if you place a chloride ion, which has a negative charge, at location C, then the force is going to be in the opposite direction, right? Because F equals Q times E, you're multiplying a negative by the electric field, you get a force in the opposite direction. Okay, so answer number 2 is correct. Answer 2 is correct. Okay. Questions? Let's try another one. Okay, location B is twice as far from the center of the dipole as location A. How do E and B compare? We just talked about this, but let's do it anyway. And again, we're assuming that the distances are far away compared to the separation size, which may not be obvious from the picture. It's got to be answer number 4, right? The distance dependence is 1 over the distance cubed for a dipole, provided you're far enough away from the charges. So if you double the distance, just think about plugging into the formula here. If you plug in 2r, 2r to the third gives you 2 to the third gives you a factor of 8, so you're dividing by a factor of 8, right? The electric field at B is 1/8 of the electric field at A, okay? So almost everybody got that. Let's try another one. At which locations, A, B, or C, or maybe combinations of them, is the magnitude of the electric field approximately 1 over 4 pi epsilon 0 QS over D cubed? Where again, S is the separation, D is the distance from the center to A or to B or to C. 87% say answer number 3, C, which is correct, right? Because now, we just mentioned this question, but if we're on the perpendicular axis compared to this dipole's orientation when we're on the x-axis. Okay, so C is along the perpendicular, and if you're along the perpendicular using the formula without the factor of 2, it's just 1 over 4 pi epsilon 0 QS over the distance cubed. Okay? No, not a lot of trouble there. So let's get a little bit more tricky. So this one even says think carefully. So let's try thinking carefully. You have 2 dipoles. You have one oriented, both oriented horizontally. This is plus minus. This is minus plus. Note there where they are compared to location capital D. And we place a proton at capital D. What's the direction of the net electric force on the proton? I highly recommend drawing a little picture in your notes, thinking about directions of fields and magnitudes for that matter. Okay, so we are converging toward an answer. We say answer number 7 is most popular. We have to look at, we're doing superposition, but we can do the superposition of just 2 dipoles, right? Since we have we know the results for each individual dipole, we can then just figure out what the net electric field has to be. So if we think about dipole number 1, let's call the one at the top here, the first dipole, and the one here, the second one, and that was oriented negative positive, right? So the electric field at location D, the electric field due to dipole number 1 points, which way? Everybody, that way, right? So that's E1. And the electric field due to dipole number 2 points, yeah, also that way. Which one's larger, by the way? One's going to be larger, right? Provided they're the same charges, we're assuming they're the same charges and these distances are the same. One's going to be a factor of 2 bigger, right? So I should draw E2 half as large, approximately. But they're both in the same direction. So if you place a positive charge there, the electric field acting on a positive charge is going to give you a force in the same direction. So it's got to be direction 7. Okay? Let's try another one. Change things around a little bit. Same question. What's the direction? Well, different question. What's the direction of the net electric field at location A? Net electric field at location A. Okay, we say, most of us are saying answer number 3. Again, you do the same thing. You have to think about the direction of the electric field due to each dipole. We have dipole number 1. Let's say the first one is the top dipole. Hold on. And the bottom one is oriented the same way, negative and positive. So here's 1, and here is 2. And the electric field due to dipole number 1 is pointing at this location, pointing, everybody, that way, okay? So that's E1. The electric field due to dipole number 2, pointing the other direction, but which is larger? E1 because, again, it's a factor of 2 bigger, right? So we should get a net electric field pointing to the right. So direction number 3 is correct, okay?